Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macey, and today I'm interviewing Avthar Sewrathan about the pgai AI suite for Postgres and how to run your AI workflows in your database. So, Avthar, could you start by introducing yourself?
Thanks for having me, Tobias. Yeah, my name is Avthar Sewrathan. I'm the head of AI at Timescale. Timescale is a Postgres database company. We build tools that help developers do more with Postgres. I'm excited to be here to chat about pgai AI, our project that helps developers build AI systems on Postgres. Thank you so much for having me.
And do you remember how you first got started working in the ML and AI space?
Yeah, I think my first introduction to ML was actually in university. I took some classes at that time. I think big data and neural networks were the main thing of the day. I think it was slightly before the craze around transformers. But yeah, took some classes in machine learning. I've always been the kind of person that's more interested in the applications of things rather than innovations in research or training or those kinds of methods. So I gravitated towards things like, for example, one of the classes I took was the implications of AI on public policy. And at that time, studying the first self-driving car regulations and use of AI and ML in the court system and stuff like that. It was with one of Professor Edward Felton, who was a deputy CTO at the White House during one of the previous years. But yeah, and then through I think the way I found myself working in the AI and ML space right now is through the lens of data infrastructure and more of the ML ops side of things and ML engineering and data engineering. As I mentioned in the beginning, Timescale, we're really a database company. Our kind of core focus is around helping developers use Postgres for more than just the relational data use cases. And with the influx of interest that we saw from ChatGPT and people wanting to build these RAG and search systems, they needed a database or a vector database in order to power that. And that's kind of how I got pulled in and how we as Timescale got pulled in to the AI and ML space. And, I've been kind of full-time working on these data infrastructure projects for AI developers for the past kind of year and a half or so. And it's been really enlightening, and I'm really glad I kind of got pulled in this direction.
Now, bringing us to pgai, I'm wondering if you can just start by giving a bit of an overview about what it is and some of the story behind how it got started.
Fantastic. So the story behind how it got started is actually really simple. Initially, we didn't actually set out to build pgai. We saw there was an extension called pgai Vector that was getting kind of popular in late 2022, early 2023. And we decided to support it on the Timescale hosted product. And we thought that would be the end of the day. Hey, pgai Vector, it has vector search. That should be all you need to power these AI applications. And then as we started talking to our own customers, people in the community, we realized that vector search is not enough to build a good AI system. And I think for people who've been working in kind of recommendation systems or building machine learning systems previously, this is probably obvious. But coming from a place where people were wanting to build RAG and search systems and kind of chat with your docs kind of applications, those were the craze kind of just after ChatGPT. We realized that hey, you actually need to go beyond vector search and address some of the limitations that would prevent people using Postgres for AI applications. And so that's kind of the genesis story of this project. It's a project and it's a suite of tools that allows developers to build AI systems on top of Postgres with the minimum amount of ML knowledge and the minimum amount of kind of previous experience and configuration. And the project really has three components today. The first one is this Postgres extension called pgai Vector Scale. And as the name suggests, it kind of works alongside pgai Vector in order to help Postgres scale and be performant for very large vector workloads. So we're talking about tens of millions, hundreds of millions, billions of vectors. Technically, how it works is that it adds a new kind of index type called streaming disk ANN that allows you to actually do more efficient nearest neighbor search, approximate nearest neighbor search. And it comes built in with things like a special kind of binary quantization and also the ability to store vectors on disk as well as in memory. And so all of that makes it easier to scale as you go from tens of millions to hundreds of millions to billions of vectors when you're building like a production RAG application. So that's PG Vector Scale. There's another extension called pgai, which is all about allowing developers to access ML models from within the database. So in pgai, the actual ML models don't run on the same server as your database. But what we do is we allow easy access and like basically bringing these models closer to where your data is to enable use cases like, for example, summarization or embedding creation, or if you want to do any kind of LLM reasoning on data that's already in a Postgres database, we allow you to do things like access models from OpenAI, Cohere, and even open source models from Ollama that's supported in Ollama, things like Llama 3.1 from Meta, things like that. And that's the pgai extension. And then most recently, we thought about the other kind of workflows that are involved in building an AI application. And despite the numerous tutorials and it feels like creating embeddings should be like a solved problem, we realized that, and after talking to a bunch of customers and other developers, that it's one thing to get a POC search or RAG application up, but it's another thing to deal with the demands of like dynamic data changes as your RAG application goes into production. And so that's where pgai Vectorizer comes in. The Vectorizer is all about basically putting embedding creation on autopilot. So we have a system that works out of the box to automatically create and update embeddings as the underlying source data changes. So in most vector databases, the embeddings and the source data are kind of divorced from each other. You have an ETL pipeline where you do your chunking, your processing, and then you create your embeddings and you add it into a database. What pgai Vectorizer does is kind of link the source data and the embeddings a lot closer together, allowing you to solve things like data staleness problems, allowing you to detect like drift in your embedding models, etc., and also solves things like experimentation and testing, which happy to get into further. Which I think given the pace of innovation today with like new models getting released all the time, that helps to compare, is it actually worth it to upgrade and like which model is best for you. So to summarize, pgai, helping developers build AI systems on Postgres. The three components are two open source extensions, PG Vector Scale and pgai, and the pgai Vectorizer, which is also an open source tool, which is aimed around embedding creation and updating.
Digging into some of that embedding workflow, as you mentioned, that's largely governed by ETL processes right now, where people will be putting it either into a Postgres database using PG Vector or a dedicated vector index. And that workflow can be fairly heavyweight, compute and resource intensive, maybe even require GPUs, depending on what you're using as the embedding model. And usually when you're thinking about workflows that you want to run in the context of your database, you don't want anything that's going to be too resource intensive, too long running, because that's going to negatively impact the applications that are getting powered by that database. And so I'm wondering if you can talk to some of the ways that you think about the trade-offs of moving that workflow into the database engine for managing those AI workflows, and some of the ways that you're thinking about mitigating the performance impacts for people who are using that database for transactional workloads.
That's a good question. And I think off the bat, I must say I 100% agree with you. It's kind of dangerous to run too many things on the same server as you're running a database, because you want your database to be able to be performant and respond well to all the user load that is coming onto it. And so what we said is that, okay, what do you actually get from having your embeddings running in the same place as your database? Is that you get the ability to manage your embedding creation and updating in the same place that your data actually lives. And so instead of having kind of systems that would, let's say, as you mentioned, sometimes you might have multiple databases, one for metadata, one for vectors, and then you have to have these orchestration and syncing systems to keep things up to date. We said, okay, how can we get the benefits of having embeddings running on the same server as the database without actually having to put up with that load and the downside of it? And so what we came up with is a system where you can actually manage the embedding creation process in a SQL query in your like database layer, because that's where the data lives. But the actual embedding creation process happens outside of the database, but you manage it in the SQL query, like in Postgres. And so what happens is, and I'll take you through two versions. One is in our cloud product, and one is for self-hosted and open source, the open source product. What happens is you have this kind of management layer and this API that knows everything about your database. It knows the tables, it knows the schema, etc. But it can communicate with these external workers where the embedding creation is actually happening. And so in our cloud product, we actually have cloud functions that run the embedding creation in things like AWS Lambda and stuff like that in order to take offload off the database. And in the self-hosted product, you can actually define where you want your external worker to run to create those embeddings. But that process and that syncing between your embedding creation worker and the database, and also monitoring, for example, how much work is there left to do. Let's say there's like 100 new items added to your database. I need to create those embeddings. All that queue management, all that syncing, all that monitoring for things being out of date or stale is handled by the Vectorizer abstraction. And that work takes place primarily in the database that then will alert these workers that there's work to do, and then that work will be done. And so that's kind of how we solve it, by saying, okay, we don't want the downside of like having extra compute load on the database, but we do want that flexibility of management and keeping things close to the data. And so we solve that by using these external workers. And if you use the open source version of pgai Vectorizer, you can kind of select where you want these workers to run. So you could use things like Modal, you can use AWS Lambda, you could just use your a separate Docker container in your environment. And so there's a lot of flexibility there. And I think as we support more ways, what we want to do is make sure that folks have the flexibility that they need to run embedding creation in the environments and in the places that work for them, rather than constraining it too much. Because I know there's some database systems out there that actually think like, hey, it's actually good to run these literally inside the database and literally inside the database server. But our philosophy is to say, okay, can we do some of the management on the database layer, but keep the actual compute processes outside the database in order to protect from, again, that overload and things potentially degrading for your users who depend on it as an application or transactional database.
And as far as that queue management, process observability, you mentioned that you can use a SQL prompt to be able to say, okay, start generating the embeddings for all of the content that gets returned in the subselect. Generally in Postgres, if you have a transaction that's executing, you can see in the PG stat table, these are all the processes that are running. And I'm wondering how that operates as far as the view that the pgai plugin has for the standard Postgres tooling, and the view that it has as far as the actual workloads that are running in that external process for doing all of that chunking, embedding generation, and then the return trip back into the storage layer.
Exactly right. And I think one thing to keep in mind is that the system really works as a combination of things happening inside the database, and we implement that via a Postgres extension, the pgai Postgres extension, and these external workers, whether it be in the Timescale cloud functions, if you're using the Timescale managed service, or on local workers or external workers of your choice. When you talk about like managing this observability and stuff, exactly right. And so what we do is actually provide functions and schema where you can actually transparently see your queue table. You can check, hey, how much of work is to be left, what has been processed, etc. What we tried to do was create an experience that we don't want to abstract everything away and say like, oh, it's magic, like don't worry about it. But we also don't want to be like, hey, you got to configure 7 different things in order to just get something working. And so for folks that actually want to dig under the hood, everything is there in the Postgres schema. We actually have a schema called AI that is kind of reserved for all of the pgai Vectorizer and pgai functions and tables that kind of work under the hood. And so developers can go and inspect exactly what's going on, and then see if there's any issues, or if there's any, to see the exact state of the system. That's all transparent in that AI schema.
So for building these AI applications, RAG has quickly become the predominant pattern for being able to increase the accuracy and reliability of those systems. That's where these vectorized embeddings come into play. What are some of the other patterns as far as the generative AI stack that you are thinking about incorporating into that pgai extension? And what are the pieces that you're explicitly saying this is out of scope that needs to be done in more of a pipelined or application centric approach and does not belong in the context of the database?
Yeah, I think from our side, I think you hit the nail on the head. We think RAG is one of those work loads where the database plays an important role in terms of being like a knowledge base to keep any private documents or any documents that you want LLMs to access. I also think another popular one that we see is just plain old semantic search, where either search engines over text data, and increasingly popular is search over image data, where we do have capabilities in pgai in the pgai extension to handle that, and for example supporting the OpenAI clip model for images and things like that, and various like image models via Olama. So one thing that's interesting to us right now, and we think the database plays a big part, is actually AI agents, especially in terms of tool use. So you can imagine, a simple example is an AI agent that can have a tool that can do knowledge base lookup, and that can be a semantic search under the hood. And the AI agent also has another tool to do a SQL query and to do a calculation over certain data that it's allowed to query. And then in that case, you can actually get RAG, quote unquote, over both structured and unstructured data. And I think SQL databases, and especially Postgres, that's kind of a very natural thing that we see because a lot of data is stored in these structured tables. And so I think, we're going to move increasingly towards that. Most of the hype around RAG today has been around like chat with PDFs and chat with text data. But I actually think the next frontier and something that we're building towards, and I think Postgres is very well positioned, is actually allowing structured data and some sort of query access to agents. And obviously, there's a whole bunch of considerations there. We're actually, in the middle of working on a set of tools and features around this. And you got to take into account security. You got to take into account predictability. And these are tough problems, and it's exciting to see the progress on them. A couple of things that I'm not sure about, and to answer your question completely about like, hey, what probably doesn't belong in the database? I think there's some interesting things around graph RAG, and there's all kinds of different architectures where, I know there's graph extensions for Postgres, but I haven't really seen too much of, implementations that have been successful there. I also think, some of this is obviously companies wanting to position themselves for AI, and I think I totally respect that. And, I think it's up to developers to decide what architectures actually work for them. But I think what's exciting is one thing that I try to do is just to have an open mind about, hey, does a database actually have a role to play here? And a good example of that is for the pgai extension. For the longest time, I had developers coming to us and saying, hey, I want to do LLM reasoning on my data that's in Postgres. And that it basically involved like either getting the data out of Postgres, doing the reasoning, and then passing it back. And there's certain cases where I was like, okay, I don't think it's actually a good idea to have the ability to access LLMs within Postgres. But there's certain cases where my eyes were actually opened, where users were saying, well, actually, what I want to do is I have a bunch of data that's in these rows. And what I want to do is basically do like a batch transform to summarize all that data, and it's already in the database. And so that inspired us to say, okay, let's build this pgai extension. Let's build that functionality where you can call an LLM, do a bunch of batch data processing on rows, and then have the result also be stored in the database in the same place. But I think for us, what we try to do is say, okay, let's give users that ability and let developers choose which parts of their workflows that make sense, rather than saying like, oh, you should use this method for everything and you shouldn't ever use other methods. I think, we're still so early in AI, and it feels like the pace of improvements is, every week there's new state of the art. Every week there's a new method that, improves things by 100% or whatever it is. And I think for us right now is just to say, hey, let's give people different workflows and different methods of doing things, and let's see how the workflow standards evolve from there. So that's kind of how I think about it. And I think it's exciting to see, some things as the preferences of developers solidify in the future, what actually becomes a standard. And, I'm obviously biased, but I think, Postgres is very Lindy in that regard, in the sense where it's been around for 30 years. I have a hunch that, a lot of AI systems are actually going to be built using good old Postgres, especially for companies that are not the scale of like a Meta or a Apple or something like that. So yeah, it's exciting to see and curious to see how this all unfolds.
Another interesting aspect of using the database for managing that embedding workflow as opposed to an ETL workflow or an orchestration engine is that it segments the work to be done. And I know that a lot of the existing frameworks like LangChain, Llama Index, Haystack, etc., when you look at their getting started tutorial, it's hey, just throw everything into this one script, but they do support being able to have discrete stages in the overall workflow and then having the LLM interaction at the front end for people to actually have that be the user experience. As people are thinking about designing their overall system architecture, the way that they want their AI application to operate, and being able to manage those context embeddings using something like a pgai, how does that factor into the overall developer experience of designing and implementing and operating that system?
Yeah, I think for us, the biggest difference and the one thing that I want listeners to take away is right now, in most AI architectures, your embeddings and your source data are divorced from each other. And you treat them as independent things when actually the embeddings are derived data. They're, representations in high dimensional space of images and text, etc. But they're intimately linked to the source data. And so what we have done is to try and reimagine, to say, okay, what if you actually linked these two things, the embedding and the source data, and how would systems look like using Postgres as obviously our playground if this was the case? And I think, when you go to, all these different getting started tutorials, there comes a time where, that metadata might become too big for the constraints of a separate vector database or something like that. And I think the biggest thing for us is to think about not just how to get to a POC and how to get to a V1, but actually how do you improve your system over time? Because I think improvement, and this comes back to like, some of the lessons that people have learned doing ML systems in the past 10 years, engineers are kind of relearning those same lessons today. And one of them is like, the importance of evaluation and testing and making sure that you understand like your baselines and how different changes improve or degrade the system. And this is especially important for like non-deterministic systems, which is, anything with LLMs today. And so what we have is with pgai Vectorizer, for example, one of the things that we made a decision about is that ability to have source data in a single table and then to have multiple derived tables with embeddings. And those embeddings can be, for example, from multiple different embedding models that allows you to test, which OpenAI model is better for you. Should you upgrade to text embedding 3? Should you stay with Ada 2? You now can do that. But the way that we did it is to say, hey, instead of asking the developer to like, because someone could just could dump all the data out and like re-embed it, let's essentially create like a synchronous replica. So all of this, the embeddings, they're synced to the source data. And so that makes testing things like different models really easy. Another thing that we found is, everyone, when they're getting started, you kind of use the default chunking settings, the default formatting settings. But how you chunk your data and the information that you put in the embedding can actually make a big difference in terms of the quality of results that you get with your RAG. And so another thing that we wanted to focus on is enable developers to test different chunking and formatting mechanisms. For example, making it easy to include data from like other columns in your database. So including let's say you're using the example of like a blog post or like a docs in the docs page, you'd have the actual content, but maybe you also want the title of the page in every embedding, because that gives context about like, hey, if this page is a blog about, GPT-4o, I know that, okay, if they're talking about like new model training methods, the LLM knows like, hey, this is about GPT-4o and not some other model. And so we made that really easy. And so it's those kinds of considerations where I think, designing a system such that it doesn't just like get you to like a POC state and get you a state where, okay, I can chat to my data, but designing it in such a way that you can improve and measure those improvements and easily test and experiment. Because I think today the rate of progress is limited by the rate that you can experiment. And so one thing that we've tried to do is for folks that use pgai is make it very easy to experiment and spin up essentially replicas of your data with different models, different chunking. And the other thing is you don't have to worry about it falling out of sync because all of that is taken care of by the system itself. So those are some of the considerations we took into place. And obviously there's ways to do this without pgi. People at much larger companies managing queuing systems, managing synchronization systems, building monitoring tools, having alerts for when your data is stale, etc. But we think for the median company that's building today, to try and solidify all of that, like that's kind of what we try to do. And hopefully that points a way to developers who are kind of entering the AI space now and building AI applications to actually build better applications in the long term. And so that's our kind of goal there.
You already partially answered the question that I was going to ask as far as some of the data modeling and schema management, particularly in the case where you have a large source blob of text that you're then going to turn into multiple embeddings because of various chunking strategies. So being able to have that kind of dependent schema with presumably foreign key references into the source text addresses that aspect. But when you are going through that experimentation cycle of I'm going to use this chunking strategy with this embedding model, no, that didn't quite work, so I'm going to use a different embedding model. That model's good. I'm going to use a different chunking strategy here. What are some of the ways that you think about signaling to other engineers or to the system which is the final state of that experimentation to say this is what we actually want to use and serve up for those embeddings, and either maintaining those other historical experiments or also optionally being able to reap older embeddings that are no longer needed because they were previous generations of embedding models or previous experimentation cycles.
Exactly right. And I think this is where we're very mindful that like there's so many other tools in the ecosystem for evaluations that we want to play well with. And I think for us, what we try to do is solve the problem of data infrastructure that allows you to experiment in the first place. And so, for example, I've talked about where, like, let's say you have this case where you see a new embedding model get released, you want to switch that model to see how it is, but you also don't want to you want to keep your existing embedding model for your production queries. And so, creating that essentially like a synchronous replica of your data with this new embedding model, that's something we thought about in the design. I think the other one is that ability to do version tracking and to actually like have this in the database. And because like a lot of the time, version tracking is in like some engineer's notebook, or it's some sort of shared Notion page or something like that, where it's like, oh, on this day we use this version, and you don't really capture it. The embedding is just a number; it doesn't have the version associated with it when you look at it in the database. And so having that, for example, where it's like you can create a table and you call whatever the embedding name is, the version is there, to actually track those things a lot easier, and to have them such that, hey, it's all in the same database. You can actually see like, okay, this embeddings are from these models, etc. And we also do it like, even if you don't name the table table X text embedding 3 small or whatever, we track this for you on the back end, where you can actually see for the vectorizer that got created, what was the create vectorizer statement and what model did it use. So that makes it so much easier to actually track and say, okay, this set of embeddings uses this model. This is all for you in the vectorizer tables. And once again, this is fully transparent, so you can just query that AI schema and find it whenever you want. And we also expose it in a UI in the Timescale product. The other one is thinking about things like gradual rollouts of new models, where, for example, sometimes you might want to do A/B testing. This is as simple as like pointing your query to a different table and to say, okay, for a certain test group of users, this is the table that we're going to use. For a certain other set of users, this is the table we're going to use. Everything else in your code stays the same. And so that kind of like experimentation and testing is something that we've thought about and try to really think about, like, hey, for the use cases that people want to build, how can we make this like super easy? And then the other thing is this idea of backward compatibility, where I've talked a lot about upgrading and like using new models, but sometimes, as we know, like certain models just get like lobotomized, and like this is famous for minor updates. yesterday Cloud was good and then today like something happened. And so maintaining that backwards compatibility is important, where, for us, we never overwrite an embeddings table with new embeddings. We always create another table. And so that makes it really easy to fall back and say, hey, you can point your queries to this new table. And if that doesn't work, or if you're seeing degraded performance in your evaluations, you can just drop it and continue with your current table. So it makes it really flexible. And that idea of just having these multiple copies that you can choose between that all get kind of automatically synced and automatically updated makes it really easy, rather than having to kind of maintain these data pipelines and maintain these things yourself. You kind of get all this orchestration for free.
You mentioned already the rapid pace of change in the AI ecosystem. You've mentioned some of the ways that you've thought about the design and scope of pgai to reduce the amount of engineering churn involved in maintaining that project, keeping it viable. I'm interested in understanding some of the ways that the overall design and scope of that project has changed from when you first started working on it to where you are today, as you have engaged with the community, kept an eye on the overall ecosystem and the direction that it's trending, and maybe some of the aspects that you decided to cut out because it was already addressed elsewhere.
So this is again, I love talking about our journey, because I think it really shows a couple of things. One is the importance of focus and like understanding like what sorts of developer problems you want to take on. And the other thing is the importance of open source and actually building upon the best of what other people have built out there, and proverbially standing on the shoulders of giants, as Isaac Newton would say. So I think the pgai journey, one of the things that initially when we started, there was a lot of complaints about PG Vector being slow, and at that time it only supported the IVF flat inverted file index type. And the immediate reaction is to say, hey, why don't we just implement this other index that other vector databases support? It's called HNSW, hierarchical navigable small worlds. This is very popular in terms of being like a graph search index. And some companies actually did this. Some Postgres companies actually like built this, and we actually said, okay, in the spirit of not wanting to build things that aren't actually going to be used, and in the spirit of actually building things that solve unique problems and kind of being additive to the ecosystem rather than competitive, we reached out to the folks who are behind PG Vector, an individual by the name of Andrew Kane. And he said, hey, HNSW is actually in progress. This is good. If you want to help, this is how you can do it. And what we actually saw, and we asked him like, hey, do you have any plans to introduce other index types? And what he mentioned is that, no, there's a lot of juice to be squeezed out from HNSW. If you guys want to explore other types, like feel free to do it. And so what we did is actually looked at some of the latest approximate nearest neighbor search research. And the specific one that we latched onto was a paper on disk ANN, which is to say, hey, how can you scale vector search? And so that's where kind of our roots started. Timescale as a company, as the name suggests, Timescale, we're all about building like scalable systems on Postgres. And so that was like a natural starting point for us, where we said, okay, how can we jump in? How can we help increase this performance and scale ceiling on building AI systems with Postgres? And that led us to build the PG Vector Scale extension that works alongside PG Vector, and say, okay, and technically speaking, it's also building upon the best of the open source work that are out there, because like we require the PG Vector extension for PG Vector Scale to work. We use the same data type. And so to say, hey guys, let's actually like be really additive to this community and like net positive, rather than trying to compete and say like, oh, don't use PG Vector, use our thing. That doesn't make any sense. And so that's like one place where we started off in terms of performance. And I think performance is still important, as a lot more to do there. But then we started talking to users, and a certain set of users were like, okay, scale is important to me, but it's important to me insofar as I want to be able to scale in the future. I might not have like the need for 100 million vectors or a billion vectors today. And so we're like, okay, that makes sense. Like if you do have that need, there's PG Vector, there's PG Vector Scale, that's fine. And that led us to thinking about, the needs of production users, and what does it actually mean to take an AI system from POC to production. And that's really where we're focused on right now with tools like pgai Vectorizer. You can think of a lot of what we do is like there's these RAG platforms out there that are very like, they're good. They're probably, most of them are designed for folks who are, in a hurry. Maybe they're a small team. You just upload your PDFs and you get a chat interface. That's good. what we thought we could do is to say, hey, how can we build something that's more transparent and that's more database centric, where folks, they want to get started quickly, but they also want to have control over how the system evolves over time as you get into production. Because I think the worst case is when things are working fine, everything is good. But many engineers who are listening know that when things are not going well and you're on call and you get questions and there's no the system is opaque, there's no visibility, there's no transparency, you can't actually see what's going on under the hood. That's when you get really frustrated, and that's when you feel really helpless, and you don't want to be in that situation. And so what we've been trying to do is design for those kinds of developers. Say, hey, you're building AI systems, but you want to have control, you want to have transparency. And that led us to things like pgai Vectorizer to try and solve some of the embedding creation and sync and updating processes. And then the pgai extension itself to say, okay, how can we allow developers who want to do some LLM reasoning from the database and where the workflow makes sense in the database layer to do that. And then in the future, as I mentioned, we're thinking about things like how do we allow these agents use case. I think agents is interesting. It's still very nascent. Like I don't know of too many agents in production today, apart from folks like the Devon, like software engineer agent, etc., and also Replit agent as well. But I think that's very interesting, and we do have some work in progress right now around that use case and where kind of Postgres and databases fit in.
In terms of the implementation and workflow, we've talked a lot about the Postgres interface of how you execute, how you manage the queues, some of the schema data storage aspects. In terms of actually configuring the embedding process, the models, the dependencies that are managed there, you said that you have the ability to run these in the Timescale workers, or you can have a Docker container or some other execution environment, but that splits the workflow between what you're doing in the database and what you're doing for all the dependency management and build process. And I'm curious how you think about being able to reduce the amount of context switching that's necessary for being able to do some experimentation of, let me choose a different model, or maybe I need a different version of LangChain or some other dependency in that execution context for the embeddings, and how you're thinking about that overall experience.
Yeah, I think that's super important, because I think what is important there is to balance that initial quick start and initial, can I get something working fast? And also the need for customization and specialization that, you might have in maybe not the first month that you start working on these systems, but in month, 5, 6, and 7. And so what we've done actually is to provide a whole bunch of out of the box functions for things like chunking and splitting. For example, we have like a character text splitter, recursive text splitter, and then what we plan to release soon after the initial release is that ability to define your own functions. So to say, hey, we have this function running, this way to run functions, and right now it runs these functions that we define. But what if we could provide a way for you as a developer to define your own functions and run those? And so that essentially reduces some of the rigidity in the system from a testing perspective. The other thing about creating new OpenAI, like defining the models and stuff that I used, what we do to make it really easy to keep up with, we keep talking about this theme, like the rapid pace of innovation, is just hook into the OpenAI APIs and to say, okay, whatever models OpenAI supports, as long as you define the model name, we are just going to use their standard libraries and their standard APIs. And if something gets added to those, we kind of automatically inherit that because we use their official libraries and the official APIs. And so, for example, we don't have anything custom for saying like, the process to embed your data with OpenAI 8.2 versus text embedding 3 small is the same. The only thing that is different from your side is the model name and maybe the dimensions that you want to specify. But everything else is taken care of you under the hood. And I think what we are trying to do in the next release is really provide more of that customization where, for example, if you don't want to use OpenAI models, which is the main model provider that we support today, you can define your own embedding models where if you want to use something from sentence transformers, you want to use something from Olama, you can hook into that instead. And so I think the next theme of pgai Vectorizer is going to be all about customization. And what I encourage folks is if they have ways or ways that they want to customize, reach out to us. This project again is open source. We're very attentive to issues in the GitHub repo.
In your experience of building the pgai suite, working with this community, figuring out how to accelerate the time to first experiment, the pace of experimentation, and reduce the overall burden of maintaining these systems, what are some of the most interesting or innovative or unexpected ways that you've seen that suite of capabilities applied?
I think there's a couple of interesting use cases that we've seen pgai as a suite of tools used. I think the first one, I'll just talk about the pgai extension. So one of the ways that someone used it was actually for moderation, where they're running I think it's some sort of blog or some sort of forum, and every message that a user posts gets cataloged in a database table. And what they decided to do was to say, hey, what if we actually could make our moderation easier by automating that with LLMs? And so they already had a workflow where every message gets inserted into the table. But what they did was actually use a trigger to say, okay, upon insert into this table, can you moderate it? And then they defined the moderation function as I think it's pg SQL, but they defined a function to do moderation. And then if the message passed the moderation, it would get inserted into like an approved table, and those other comments that are shown. And if the message didn't pass, that would go into a flag table where like a human could review it or something like that. So that was really interesting for me as a place where actually making these capabilities available on the database layer helps, because then you have all these database level abstractions to deal with it. And a lot of these workflows, if folks want to deal with it on that layer, like just giving people the ability to do that. I think the other interesting thing for pgai Vectorizer is just how we underestimate how busy teams are in order to do experimentation. And I think from the people that we've talked to, both current Timescale customers as well as folks that are just using the open source stuff in the community, simple things like you would think, folks as like within 3 months of OpenAI releasing like a new embedding model that promises to be cheaper and perform better, most developers would upgrade. But you'd be surprised at the amount of developers that's still running Ada 2, the old embedding model that costs a lot more. And when we asked them, hey, it seems like it's a good idea to upgrade. Why wouldn't you? They're like, hey, man, we have so much to do on the product side, and it's just something we keep putting off in our sprints, and we just put this off for months and months, and we just never got around to it. And so for us, I think one of the hopes is that pgai Vectorizer and tools like it enable folks to do these things that it's very easy to put off. It's tedious work. Enable them to do that and actually like benefit their teams. I mean, like some of these models have like huge cost savings, and the users get the latest and greatest, in terms of performance, etc. So I think like solving that non-usage and non-experimentation that's going on, that's the biggest thing for me, and what I hope is kind of the biggest unlock for new folks that use pgai Vectorizer is like now it actually makes it easy to do experimentation. And even simple things like, hey, upgrading your embedding model, what used to take like maybe a week of work that you'd have to allocate one engineer to that you keep putting off, can just be a day or a few hours at most.
In your experience of building this extension, iterating on its capabilities, and working with the members of the community to understand its utility and the direction to take it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think one of the big things is trying to keep up with all the different levels of the stack and like the different integration partners that people are using. Some people, parts of their system is like in LangChain that they're trying to migrate. Parts of their system is in, some other like RAG framework that, some developer got started with, and they're trying to like, integrate things together. So I think just dealing with those legacy, and it's funny to say legacy because it's like maybe something they wrote like 6 months ago, but now it's kind of out of date, and just kind of dealing with that and having to kind of help them migrate away from that, or how do you integrate that into the current way of doing things. That's been interesting. The other thing I think is that's been really heartwarming for me to see is just the level to which like people care about open source software, and the way that developers are willing to contribute fixes and features and things like that. that, really they don't have financial incentive to do this. Like I think part of our goal for pgai is to make the software as accessible as possible to everyone and not make it something that's just proprietary. But the extent to which we have feature requests, the extent to which we have people in our Discord or even in the GitHub issues helping each other, it's really been great to see. And I don't mean to use this as a meme, but like reconfirmed hope in humanity a bit, where it's like, hey, this is just folks who find this kind of thing interesting and want to help each other. I think that's been really great to see. Yeah, I think that would be my answer to that question.
So, for people who are interested in building these RAG or semantic search applications, what are the cases where pgai is the wrong choice?
I think right now, one of the places where Postgres in general can do better is where you want to have full text search and where your application has a heavy reliance on full text search. And this is things like BM25 and stuff like that. And I think what we've found is that in cases where you want to do hybrid search, you can kind of get away with using PG Vector, PG Vector Scale, and then the native Postgres search. I think it's called TS Vector or something like that. You can get away in some cases, and then you can kind of, your re-ranking process can help you. Or say, for example, you want to do lexical search on only the titles and stuff like that, like just really simplifying things. But if you have a heavy reliance on full text search rather than vector search, I think pgai is really built for things around the vector search, these kinds of embeddings based application. And I think some folks in the industry are doing interesting things. I think there's ParaDB. There's also some like proprietary solutions. Many of them are not quite there yet, such that it's a seamless kind of hybrid search experience or a seamless full text search experience. And so that's where one of those things where if you want to have a search engine built with heavy full text search requirements, Postgres isn't quite there yet. Hopefully it will get there in the future, and hopefully that future comes soon. But today, that's one of the places, honestly speaking, where the ecosystem is not quite ready.
As you continue to invest in and mature the pgai project and suite of capabilities, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
Yeah, I think there's a couple of things. The first one is, starting with what we've been talking about around pgai Vectorizer, just making this process of embedding handling, embedding creation, experimentation a lot more flexible and customizable. So I talked about, today pgai Vectorizer supports mainly OpenAI models. We have some out of the box, like commonly used chunking and formatting functions that are used. Just making that really customizable, making that so that people can define their own functions, their own embedding processes, and have that run within the pgai Vectorizer kind of framework and kind of system. That's one thing. And then the other big thing, I think I've talked about this earlier as well, is that excitement of unlocking the capabilities of structured data with LLMs and with agents, and like building the abilities for agents and LLMs to query Postgres tables. And I think some part of this is like text to SQL. Some part of it is like really defining a great developer experience around this. This is something that, we're excited about. We have, for example, blog posts about how you can build this yourself today, just using Postgres and the existing, agent frameworks and the existing frameworks out there today. Like, for example, Instructor is a popular one on Python. But I think there's a lot of work to do there. And so that's another interesting area that we're watching closely.
Are there any other aspects of the pgai suite, the work that you're doing at Timescale, to improve the experience and reduce the maintenance burden of people building these vectorized workflows that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think the final thing that we can close on is a kind of a theme that's been running throughout this, which is the choice of data infrastructure that you use. And I think for us, we're a Postgres company. We started off, Timescale started off as a company that built a time series extension for Postgres. This has now evolved into things like real-time analytics and time series as well. And then now we have this pgai project and pgai suite of tools, which is all about AI and vector. The biggest thing that I would encourage developers to take away is that like you don't need to learn something new in order to build a state-of-the-art AI application. Like the tools that you already know, that you may already have in deployment, that you have familiarity with, especially databases like Postgres, you can get a very long way. And for the work that we've been doing, we're trying to make it such that developers kind of never have to switch away from the tools that they already know. And so that familiarity and that ease of saying, okay, if I want to build an AI system, I know how to use Postgres, I can use pg Vector, I can use pgai Vectorizer, I can use a pg Vector scale extension. That's really cool because it means that like you don't have to learn a whole new system. You can transfer all of that knowledge that you have from maybe your existing years of using Postgres. And so, that's one thing, and I'm all for seeing innovation. I think some of the other folks in the space are doing really interesting work with just focusing on just vector search and kind of embedded vector databases and stuff like that. But I think from our perspective, making Postgres better for more of these use cases that are outside of just relational and transactional data handling, I think that is the theme of Timescale as a company, and a theme that we're seeing where it's like there's a popular meme online like Postgres for everything. Like, I don't know if you know the midwit meme where it's like, hey, the person who's like kind of dumb uses Postgres. The guy in the middle is like, no, you need to have like 10 different databases. And then the Jedi on the end is like, yeah, just use Postgres. And so that's where I'd like to end is like, hey, we're doing our best to help folks just use Postgres for AI. And if there's any way we can make it better, I'm all ears, and I'm excited to hear what listeners have to say.
All right. Well, for anybody who does want to get in touch with you and follow along with the work that you and the rest of the folks at Timescale are doing, I'll have you add your preferred contact information to the show notes. And then as the final question, I'd like to get your perspective on what you see as being the biggest gaps in tooling, technology, or human training for AI systems today.
The biggest gaps in tooling, technology, or human training. Is that from an engineer's perspective or also like just people using AI systems?
However you want to think about it.
I think my biggest gap that I'm seeing is the willingness of people to really give AI and integrate AI into their everyday workflows. And I think there's two layers to this. I think the first one is there's a wonderful book by an academic out of University of Pennsylvania called Ethan Mollick called Co-Intelligence. And one of his rules for AI says, hey, like always invite AI to the table in everything that you do, because that's the only way you will discover what he calls the jagged edge of AI, where the frontiers of AI capabilities, and that's the only way you'll be able to separate fact from fiction when you see claims made by other companies that are just trying to sell you dreams versus companies that are actually building useful things or people that are building useful things. So I think like I'm just surprised at the continued, like there's a certain set of people who are like super all in on AI, and there's other folks where you'd expect a lot more AI usage. And I think, for example, one illustration of this was, last year before OpenAI made their latest models free to use, everyone was judging frontier AI capabilities on GPT 3.5, which had been old, and GPT 4 had been out for a long time. And so I think just that willingness to test as a means of like deciding for yourself and like thinking for yourself, that's very important, rather than seeing what people on Twitter are saying and kind of going that direction. The key thing is like that willingness to invite AI to the table and use AI in your general workflows, whether it be coding tools, whether it be writing, whether it be any kind of thinking. I think there's a lot of interesting benefits to get out of there. And I think the only way you find out is by experimentation and is by usage. And I don't think we've reached peak AI usage and experimentation by any means yet. And so hopefully that becomes even more accessible to people and even more popular. And that ultimately helps people at the end of the day.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been putting into the pgai suite of tools. It's definitely a very interesting approach to managing those embeddings, increasing the pace of experimentation, and increasing the maintainability of those stacks. So appreciate all of the time and energy that you and the rest of the team are putting into that. And I hope you enjoy the rest of your day.
Thank you, Tobias. And thanks, folks, for listening. I really enjoyed being on this podcast today, and it was a lot of fun.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcasts.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.